problem, actually. We'll be able to start doing all the law sides, law cosides, word problem stuff. My best guess, as far as the first part of the trait quizzing of all this unit stuff, is a coyote. Hey, see it walking through there? It's definitely not a deer. So, it does look more like a dog. You want to go get it? I just happened to glance up and I saw something move. I'm like, huh? What? Where? I'm so. Okay. So I'm in the. Alright, so see the tall. See it there? I need some binoculars. Who's got binoculars? I got some binoculars. I do. Where? Anyway, law signs. Guys, it's okay. It's not gonna. It's looking for a road runner. If you see a coyote with anything from Acme Corporation, run away. It's going to explode. If you've never seen Wile E. Coyote, he was always ordering stuff from Acme.
Driving by town, and we saw a dog. We're like, oh, like there's a dog being walked.
Yeah.
So then we got closer because there was no footsteps here. We're like, did a dog escape? And then we got closer.
Yeah, it's coyote. Yep. We have a bunch of those out in our fields back by us. Anyway, law signs. So you guys you saw this last year. Law signs is for when you don't have a right triangle. Okay. And with law signs, you guys basically were setting these things up a lot last year where you had an angle and a side opposite. And that's kind of the idea. If you ever get an angle and a side opposite, you're going to wind up using law signs. Okay. The formula for law signs is fairly simple. It's just the sine of an angle over the side opposite it equals the sine of another angle over that side equals the other side of the other angle, and so on and so on. Obviously, you're not using all three of those equations, all three parts at once. You use one part to solve for both sections. Okay. Again, like I said, this is very, very straightforward. It's a lot of button pressing and understanding how to solve systems. Well, there's another one.
Oh my God.
Or is it the same one? Oh yeah, there is. Look at that. This is cool. You tell everybody there's coyotes out there too.
Is that the thing?
Okay, let's go back to math now. We should tell people. They're done. For example, here's what happens. What happens a lot of times with law of science, there's actually two different things there's four things we have to worry about in the long run. The first thing we worry about here is if you have two angles in any side where you have your angle side or angle side angle case, that's when you're going to use the law of sines. If you have three sides, you obviously don't have an angle, which means you'd wind up using law of cosines. We'll talk about that tomorrow. And then obviously if there's another one, if you have what's called side angle side, you have to be very careful with that one because there is a possibility that something crazy may or may not happen. We'll get to a couple of different scenarios of this throughout. You guys did law of cosines last year too, right? That was the long form of cosine.
I don't remember.
It's a formula that's really easy to use. So, for example, what I want to do here is you're going to be given information, but what should you always do? Draw it out. Always draw it. Okay, just draw a rough triangle, label it, and go through it. And as you go through these things, every single time, they don't have to be to scale, they don't have to be perfect. You just want to get a visual representation of what you're actually doing. Okay. If I label them A, B, and C, I have 103, 28, and 26 here. Okay. Do you guys agree that triangles have 6 total parts?
Yeah.
3 angles, 3 sides? In this case here, how many do we already know? 3 of them. Okay. That means we have to find what parts? Well, we got to find angle A. Bless you. I always make a list of what I have to find. I got to find angle A. I got to find little a. Remember, little a is the side opposite. And then I also have to find little c. Okay. So far, so good? What's the easiest thing to find? A. Why?
Because one, you have to add the other two.
Good. Easiest thing to find here is always going to be the missing angle because you just subtract the other two from 180. If you do that, what do you get for angle A? What was it, 49? So we have 49 here. Okay? Now, here's what we do. The given information for us with the angle and the side opposite goes around B. Are we okay with that? So what I like to do is I always draw just a little arrow. That way I know what parts I'm going to use. So I'm going to say the sine of 28 is to its side opposite as the sine of 103 is to its side opposite. That's how I get little c. I do that again to find little a. Sine of 28 is to 26 as the sine of 49 is to a. Lot cross multiplying, correct. Now, in this case here, we need, since you'll start to realize that your variables, if you're solving for a side, are usually going to be in the denominators. If you're solving for an angle, we have to do other stuff as well. So in this case, what I would do is I know that I have to cross multiply here. If I do the change-o, and then I bring this up. So all I have to do, move this up real quick here. All I have to worry about is this. C will equal 26 sine 103 over sine 28. Okay. Change-o with the C and the 28 sign, and bring the 26 up to multiply. Same scenario for the other one. Little a is 26 sine of 49 over the sine of 28. Okay. It's still not responding. That's really annoying. Anyway, so press O buttons. Alpha y equals fraction bar 26 sine 103 over sine 28. I got 53.96. And then the other one is 26 sine 49 over sine 28. And I got 41.8. Everybody okay with those two? All right. Now, really the only thing that you can do now, just to see if it makes any sense, since you can't check it on Pythagorean theorem or anything, is if I put that, what was it, 5396, and then the other one was 41.8. Do those angles and the sides opposite make sense? Remember what I mean by that?
So like the biggest side length should.
Correct. That's exactly right. Remember, the largest angle should always be across from the largest side, and so on and so on. So you're ready to leave it?
Oh, they are.
Those are healthy. Okay. Not terrible? Not terrible.
Maybe we could learn the more.
Okay, let's try another one. Okay? Once again, draw it through. Again, what do you have to solve for? Two angles and a side. Yeah, we got to get angle C, angle B, and little b. Always make a list. No. What? Set it up. Use A to start with. So obviously, before I get to work with anything with B, I have to first find angle C. Now, do you guys remember what you would do first here?
Yeah, you're gonna.
You do the thing, yes.
Yeah.
Well, can't do the inverse until you get everything to one side. So at this point here, you're right, you'll have to use the inverse to get to the angle. So what you want to start with is just your 10 sine 18. 10 sine 18 divided by 16, hit enter. And now that decimal equals the sine of C. So you have to do your second sine of your answer. And I get 11.14. Okay. So far, so good? Okay. Now, excuse me. What do you do to find B? Yeah, add together and subtract. So 11.14 plus 18, 180 minus that, I get 150.86. So I do the same thing. That's little b. And then, let's see, so it'll be 16 sine 150.86 divided by the sine of 18. I got that. So B was at 150. When I go back to that triangle, though, when I went back to that triangle, what scenario was that? What did we start with? What were we given? An angle of two sides. If you looked at it, though, how was it set up? If you think, go back to remember how we did congruent triangles and stuff?
Yeah.
So this was our angle, and then these were our two sides. What would you call that? A mess, yes.
Wait.
It's not ASA, because it's the angle between the two sides. It's angle side side. So
Right, you can't do that.
Do that. Do not spell that. Do not spell that. Hey.
You cannot spell
now you can say it in my class.
Oh, no. No.
It's okay. We're not in that class, are we?
We're not there anymore, Tyler.
So here's the scenario. This is where things in Algebra 2 get a little weird.
No.
There runs a possibility whenever you have angles side side that you can have more than one triangle. Now, this is where you're going to have to trust me a little bit. Do you guys agree? Bless you.
No.
Oops. No. Do you agree that if you go around a circle, you start at 0, and if I start at 0, I'm going to go around counterclockwise, it goes to 360 degrees? You okay with that? Okay. Now, if this is 0, what's here? 180, good. What's here? And then, okay. Now, for example, if I put an ordered pair, and what do you know about the x and the y coordinates in terms of positive, negative? If they're in the first quadrant, what are your x and y coordinates? They're both positive. So here it's plus plus. Now, if this exact point reflects to here, negative, positive, okay? Now, here's what's happening. If I say that this angle is 40 degrees, that's from here to here, okay? That means that that angle has what we call terminal side off of 0, it comes up 40 degrees. There is a point, if this goes to here, did the y value change? If it stays horizontal, the y value does not change. Is the y value positive or negative here? It's positive. So that means that coming up this direction, it's up 40 degrees from there. Which means, what would this angle to here be?
130.
140. Okay. Everybody okay with that? Okay. If I come 40 degrees from 180, I'm at 140. Everybody okay with that? Now, here's what I would like you to do. In your calculator, real quick. I just got to restart mine. Calculator. I want to show you what actually happens here. I'll just use my other one. Hello. I just need to use. So, what I'd like you to do real quick is I'd like you to type in cosine 40. You're in degree mode, just hit the cosine of 40. I wanted to pick numbers that had decimals so you didn't have to worry about special triangles or anything like that. What do you get? Okay. Now I'd like you to then hit sine of 40. Like 6.4-ish? Okay. Now, That means, well, what comes first in the alphabet, cosine or sine? What comes first in the alphabet, x or y? Remember what I told you to write down?
Oh my gosh.
Oh my gosh.
Hold on. I remember. Hold on.
How do you spell her? I have it.
So 0.77, 0.64-ish for both the x and the y coordinate there. Now, do the same thing. Do the same thing at 140. What is the cosine of 140? What is the sine of 140? Do you see what just happened? As it rotated over, it's what we call this is called a reference angle. How many degrees it's up off of the x-axis? It just moved over horizontally. The ordered pair didn't change. It only became negative 0.77 and positive 6.4. What do you think would happen if I moved it vertically down to here? They would both be negative. Now, what would this angle be then if this has to come down 40 degrees? Let's shoot 20, very good. And then you'd get negative 0.77 and negative 0.64. And then if I go back to here, what would it be? 320. 320, and then it would be positive 0.77 and negative 0.64. And those values are because of what we call this reference angle of 40 degrees, up or down. Yes, ma'am? When did I tell you to write this down? What, September? Something like that?
Yeah.
I just said, hey, this is going to come up again at some point in time, probably in February. It was something about
From August 28th.
August 28th, I said something about what comes first in the alphabet, sine or cosine. And that was just kind of from there. This is why some of this stuff is possible. So here's what's happening.
It was called shadowing.
This is actually
All right. So if I go back real quick, the first angle that we found, was that first angle acute or obtuse that we found? Acute. Okay. So here's the rule. This is what we call the ambiguous case of the law of sines. The ambiguous case of the law of sines means that it is possible to get a secondary triangle when you have angles side to side.
Is that what we did?
Yes, sir.
So misspelled it. I thought it was because they spelled it wrong.
No, we always say there's no ass in math. We chant it that there's no ass in math because that's not a way you can prove triangles are congruent. Because you could get this because it could have the ambiguous case.
She's a liar.
Sure. If you want to go tell her she's a liar, go for it.
Can we go right now?
Yes. Go over and say angle side side exists.
She ends her class.
Yeah. Anyway, so here's what happens. When we have angle side side, we had first started with, help me out here, we had A, B, and C. The A was what, 14?
Yeah.
No,
18. And, oh yeah, and then the other side was 14.
16.
18, 16. And then what was little c? 10. Okay. So what we found here was we found that this first angle C is possible to be at 11.14. What we do then is there's a trick to figure out if you have a secondary triangle. What we do is we check the supplement. Supplement angle is when I take whatever angle I subtracted from 180. Are we okay with that?
Yeah.
Okay. So what I want to do is take 11.14 and I subtract it from 180. What do you get? What is it? 168.86. Okay. So what I'm doing now is, if you think about it, that 11.14 degree angle in the first quadrant has a matching angle in the second quadrant that comes up 11 degrees from 180. That's where we're getting this. So it matches it at 168.86. So basically what I'm saying is, if I did the sine of 11.14 and I did the sine of 168.86, it's the same value because they mirror each other in the two quadrants. They're horizontal, the points are horizontally apart from one another. They're reflected, if you will. Okay? Be okay with me on that so far? All right. Now, here's what we do. I take this and I'm calling this now, this is my possible C prime angle. Okay? It's not necessary that it's going to work, but it's something that I have to check. So what I need to do is I have to take my original angle of 18 degrees that was given to me, and I add that back to it. Am I above or below 180? Above. So will I have two triangles? No. That's the check that we do. This is over 180, so it's greater than, this is now greater than 180, so there is no second triangle. If there is a second triangle, that value will be less than 180. Okay? And we'll get into how we draw this up and do it as we reset it. Textbooks, online tutorials, all that kind of fun stuff, they go through this long-winded ways of showing and checking to see if it is possible for a secondary triangle. The easiest way that I have ever seen is to always check the supplement. If the supplement has enough degrees with the original given angle to make a third angle, then to get to 180, you have two triangles. If not, you say no second triangle and just go on from there. And we got more examples, don't worry. Yes, sir? Oh, I'm sorry. Yeah. So this would be, well, I should have just added this up, 0.86, 6, and then what was that? 8. So that is bigger than 180, which means you can't have that third angle. Okay. So it looks a little weird, but it stems from this idea of how things get reflected into the other axes. Okay? That's where it came from. That's why back in August I said, hey, this might come up again in conversation. Okay. Let's try that. Let's try another one. Okay. Let's try another one. In this case here, it's again angle side side, isn't it? But if you look at it though, the first angle you're given is already obtuse, which means can you have another angle that's obtuse? No. So you know no matter what, the worst case scenario is that this would be one triangle. Okay? But look at it closely. Oh. Why? Oh no, I would say that, but why is this not a triangle? Yeah, Peter. Exactly. So that's the other reason why I have you guys draw pictures. Because if you look at it right away, is this possible to even make a triangle out of this? No. Because in order for this to work, the 7 would have to be over here. This is what you're given, so you say no. All right. It's the idea of going back to the old, go back to your biggest angle, biggest side, and so on. Okay? All right. So I'm going to skip that one here. The other thing that you can do is that there's this really, really, really awesome way of finding area of a triangle that's not a right triangle using this. And this is going to work for when you have side angle side. Okay. Now, what's nice is this is the area of a triangle. We'll do more ambiguous later. Think of it as 1/2 side angle side. Well, let's see here. think of it this way. This is for when you have side angle side. All you would have to do is just 1/2 the side times the sine of the included angle. That's it. And it gives you the area of the triangle. Yep. What they do here is they write it out long form with trying to, it depends on what sides you're given and all that. All I want you guys to remember is that if you have side angle side, which is what this is, if you have side angle side, so if I draw my picture here, A, B, C, I have little b at 12, little c at 17, and A at 103. See how that side angle side? All I have to do is 1/2 side, sine of the angle. There's my area. This is a nice trick. This shows up ACT stuff. Well, they'll give you the glass for the area of a triangle that's not a right triangle.
Easy, we can do that.
Good.
We're taking the SAT. That's not.
April. Yeah. It works like I said, and this works really quick. This one's really easy. Okay. We do have time. Let's see if I got time to do one more ambiguous. So we did that. So again, if you have, this is kind of the idea for the side angles, for the, what do you call it, the ass in math, or side angle, pardon me. If your given angle is obtuse, and the side opposite the angle is larger than the other side, it's all good. Alright, if it's not, that like we just saw that other one, it's not going to be possible. Alright, so going back to the idea here is, if this is 103, and this is 6, and this is 10, will this work? No. That's why we say it's not going to work. Now, if this was 60, and that's 10, would this work? Yes, all good in the hood. Okay. Like I said, the textbook goes into this whole long-winded version of all of this junk. Why would you ever do that? Exactly. That's why I say, if you are the, what's that? What happens with this stuff is that, did you guys ever do the constructions with, no, not with the compasses, but there was a way of doing side angle side on the Chromebooks where you.
Oh, yeah.
There was one where you had to match them up where the side angle didn't work. This is why it doesn't work, because you can have that extra angle that makes it bounce. Okay. Oh, I'm not going to worry about these one today. We're going to run out of time. We'll worry about this one tomorrow. So, give these a shot. These shouldn't be so bad. I think, if I'm not mistaken, I pulled the ambiguous ones out of here. But just in case, always double check it just to see if it by chance did get the ambiguous one. What I'm going to do for tomorrow, because I got the NHS selection stuff, is I will probably just do a law of cosine video. I'll make that one for you guys. And we'll just spend the day on Thursday talking about ambiguous case and showing up the examples on that stuff on Thursday. And we'll go from there. Sound decent? Then we'll probably start doing more problems then second half of Thursday, and we'll do those into Friday. I didn't think I'd have enough time to get through ambiguous, but it was worth a shot. What's up? What's that? Ambiguous ones, I took them out of this set here, but if the second angle you find is find it supplement, see if you have two data together that's bigger than weight. I wouldn't worry so much about it. Yeah, make sure you guys tell Kelly she lied. There is ass in math.